Alright, Chapter 5, Special Purpose Machines. Government India, Ministry of Railways, Railway Board, Indian Railway Track Machine Manual, 2nd edition, September 2019. Alright, Special Purposes Machine, Chapter 5, Special Purpose Machine, Rail Grinding Machine, or RGM. Rail grinding is done to reprofile the railhead, taking into consideration profile of the rail wheel with the optimization rail wheel contact band, thereby making the rail wheel interaction favorable. The expected intersection increase for the life of the rail and wheel apart, reducing the rate of the generation defect for the rails of the Indian Railway using a 72 stone grinder with the RGI series Loram US make grinding machine. Purpose of the rail grinding. Rail grinding reduce the contact stress of the maintain favorable settings, steering of the wheels, the result of the reduction of the wear and tear of the damage of the railway wheel surface. Rail grinding shift the contact with the majority of the wheels from the area with the surface defect of the rail to avoid further growing of the defects. Rail grinding avoids contact of the tread with the misaligned welds, thus resulting in reduction of the hunting of the hunting on a straight track, avoiding consequent damages. D. Remaining rail grinding helps control the damage because rolling contact fatigue removes cracks for the initial stage of the development, thus avoiding further growth deeper into the rail, thereby reducing weld and rail failures. Their cracks will not be allowed to reach a stage of a high growth and will be ground. Initial storage of the ground growth is slow. Rail grinding removes corrugations and other irregularities from the rail top, resulting in better rail riding quality. But wheel radius flatter than rail radius for the new rail passage for the traffic. Rail radius tends to target the flat and increased width of the contact with the band within not desirable to causing hunting damage to the rail surface. Rail grinding will restore the rail crown radius and then reducing this damage. G. Rail grinding remove the white marcinic layer on the rail top, which causes the development of cracks due to the brittle nature. H. Due to the different hardness of the rail heat affected zone near the welds, the dip formation starts in the vicinity of the weld due to the differential wear. This weld dip promotes rolling contact fatigue. The various forms also causes squat formation. The dip formation will avoid irregular rail grinding. Rail grinding helps the reduction wear due to reduce the contact stress by the adoption of engineered rail profiles. J. Whether other surface defects such as the wheel burns, scabs, low, high welds, etc. exist on the rail grinding helps taper down the defects after grinding pass goes as to reduce damage due to these effects. 2. Advantages of rail grinding. The advantages will accrue with the rail grinding can be summarized by given below. Increase the life of the rail and wheel. This appreciably increase the life of the rails of after rail grinding. Life of the wheels will also be reported increase the grinding of the rails. B. Improved reliability as of the defective generation rate of the rails imported with reduced to 1/4 of the sum of the railway system. Reduction of the failures will lead to increase of the safety and reliability of the train operation. Less tractive resistance due to lesser impact, therefore saving the fuel consumption. Improve the reliability of the USFD testing due to smooth and cleaner rail surface reliability. Ultrasonic field testing will improve the reduced track geometry. Deterioration track geometry will retain a longer period, requiring tamping of the track should come down. Reduced degradation ballast due to the lesser impact. The degradation rate of the ballast will come down. This should bring in reduction frequency of the deepening the screen of the track. G. Less noise. The noise level goes down after rail grinding. Reduced derailment proneness. The overall improvement of the rail wheel interaction will result in better safety performance. Important assembly rail grinding machine. Components of the rail grinding machine consist of the formation of 6 wheels which move as the train composition shown in Figure 5.1. Major components of the rail grinding machine are explained below. Front control car number 1, grinding cars number 3, 3 numbers, water wagon number 1, camp coach, rear control car number 1. Our Figure 5.1 shows the control car, 3 grinding cars, and then a water wagon and a camp coach. Front control car with the air-conditioned cab with both driving and grinding operation. For all grinding operation, the machine is having 2 touchscreen consoles known as the human machine interface console. These consoles are used various settings, selecting the pattern viewing the machine working. There's such a hydraulic, pneumatic systems, and domestic mode is assembled. There are 2 CCD cameras, one monitoring the FCC showing the view of the track in front as well as the rear of the rail grinding machine formation. All driving and brake lever gauges switch are available on the front desk. Important dimensions of the FCC are given the armature 5.1 components of the front car control car figure 5.2 below. Shift of the cab, air compressor, electric locker, water tank, the frequency converter, the obstacle detection, driver truck, the power bogies, belly tank, the 10,000 liters of water tank, the rear corrugation analysis, laser-based rail profile measuring test system. Alright, B, grinding car. The components for the grinding car are given in figure 5.4 below. The dimension of the grinding car are given in the annex for 5.1. These three grinding cars, each grinding car consists of 2 grinding carriages, but each carriage have 12 grinding motors, 6 on each side. The grinding carriages known as the buggies provide with the separate wheels of the buggies for the kept of the raised and locked position during the idle running of the machine. Grinding motors can be positioned up and down condition when the bogies are down and running on the track. During the working mode, the grinding motors are raised only in case of obstruction while the bogies keep running on the track. Alright, shows the grind car, cab, hydraulic power generator, engine, dust collector, air compressor, power bogie, carriage, full fuel tank. Water tank wagon. Water tank wagon is attached to the grinding machine to ensure sufficient availability of water to take care of the fire hazard. Wooden sleepers and track with the dry grasses and track on access to spectacle catch fire to do the heavy sparks generated during the grinding operation. Water is sprinkled through with a tie sleeper air with the sprays and ditch. Says area sprays provided on both front and rear extreme grind cars. Water sprinkling is done using spray in advance of the grinding operation to wet sleepers assessed to prevent fire. The machine is equipped with a 30 horsepower pump, water cannons, fire hose, and fire extinguisher, fire detection system to take care of all fire hazards. Total water storage available on the machine is 75,000 liters. Camp coach come rear control car. The camp coach is driven with the controls as known as the rear control car. With the rear control car cameras are mounted with the rear control car overlooking the track with the rear of the image is also displayed on a monitoring FCC. This helps sequence the motors up and down as well as looking with any of the trucks to the rear side of the train while carrying out the grinding in the reverse direction. Here shows the camp coach rear car control cab. Observation room control cab, cab 1, 4-seater toilet, cab 2, 6-seater dining, cab 3, 4-seater toilet, attendant, and generator room. Alright, corrugation and analyzer with the mount of the front axle, rear egg bogie with the FCC with the front measure with the rail corrugation during the running of the machine gives an idea of the level of the corrugation present on the track, facilitated with the decision with the depth of the cut. Obstacle detection system gives the warning of the senior service to junior executive track machine in case of the obstruction found in the track. They can take an appropriate action to getting a signal. 4. Rail profile measurement system optical. The machine has either the 2 layers based on rail profile measurement system measured the railhead prior profile before and after grinding. These measurement systems are mounted in an appropriate location of the FCC and water wagon. Dust collection system is provided with a machine to suck up the iron particles generated during the grinding and store with the chamber so that the iron fillings are not scattered along with the track. They also do with the foul environment. Iron fillings are harmful when the human beings are likely to cause damage to the eyes. The dust collection chambers can be emptied as per convenience as for the after grinding run. Brake system. Following brake system provided with the rail grinding machines. Indirect brake of the brake is applied with the machine with a couple of camping with the coach wagon of the automatic when the air pressure of the brake line releases through valve A9 or drops. Direct machine brake. The brake is directly applied with the rolling socket attached with the machine. It is used with the low speed braking. Emergency dump brake is applied directly on each rail socket of the machine in case of the emergency immediate stopping. Parking brake, hand-operated brake are provided on each of the grinding cars for stabilizing. Grinding strategy. 503, strategy. The metal removal during the process of the grinding and frequency of the grinding is decided with the control of the rolling contact fatigue. Corrective grinding. Grinding done for the complete removal of the corrugation surface to the effects of the one cycle of the program required with the number of passes of the same continuous box to achieve the engineered rail profile is corrective grinding. Preventive grinding. Grinding done with initial state of defect generation, preventing grinding. The preventing grinding is done more with the frequently with the amount of the metal removed during each cycle that is much less than compared to the corrective grinding. Preventive grinding is considered to be a better approach since grinding can be done in single pass at a high speed and the head hardened layer over the rail top is not removed. Preventive gradual grinding. On Indian Railways, surface defects of the section identified with the rail grinding has passed the stage of the preventive grinding. The corrective grinding, or IR, is not desirable on account of the issue with the blocks and likelihood of overall of removal of the head hardener layer. The strategy of the preventive grinding has been adopted when in metal removal is done more than that required in the case, and preventing grinding but less than required for corrective grinding stage. Preventive grinding expected to be achieved on IR after 3 to 4 cycles of grinding. Targeted rail profiles. Alright, your target rail profiles are a rail profile achieved after the rail grinding was designed to produce the minimum contact stress during the rail wheel interaction. The nature of the rail wheel interaction is different on the straight curve compared to the curved track, with different with the mild curve, with the sharp curves for the high rail and the low rail of a curve. The target rail profiles to be achieved with the grinding and are therefore different for each of these locations. Are designed to produce the least stress during the rail wheel interaction patterns. Grindstones are positioned across the railhead to achieve the particular pattern of the removal of the metal. The position of the stone is characterized by the angle of the rotation axis of the stone from the vertical, depending upon the angle of the location of the grind by each of the stone of the railhead will vary. Power grinding motors can be controlled. The pattern will be defined by angle and the power. Each of the motors working on the railhead grinding of a different location is required to be select one. The design program patterns achieve the target rail with a profile in one or more passes. Different patterns may be to the left or the right with the rail on the same track. Metal removal of the railhead will depend upon the following factors: the number of the grindstones working on the rail, the power of motors, speed of the grinding, number of the passes, hardness of the rails, character of the grindstones, depending on the specification of the manufacturer. G. Position of the grindstone, angle of the axis of the rotation of the stone. Grind Data Management System, the GDMS. Grind Data Management System is an integral automatic data acquisition, data management, quality control, reporting, planning tool of the rail grinding. It is a software-based system which fed with the track data, different pre-decided patterns, proposed target profile with different track geometry structure. It uses the details, suggest patterns to follow the grinding different locations. It uses a laser-based rail profile management system, void running as wheel on the rear of the grinding machine to record the pre- and post-grinding rail profile by taking measure run in advance. The general grinding data management system is having the facility recommending one of the pre-defined patterns to get the target rail profile for existing rail profile. After the measuring the existing rail profile, achieve the target rail profile. The grinding data management system recommends patterns and speed to get more efficient results. Alright, grinding quality index. The post-grinding profile achieved is compared with the targeted rail profile of the grinding data management system index known as the GQI, or grind quality index. It is displayed during the run. The grind quality index gives you an idea of the variation with the target rails profile of the grind quality index values. 100 means that have been achieved with the target profile within specified tolerance. A lower value indicates the deviation in the grinding quality index. Value of 80 or above can be considered acceptable. Capability of the rail grinding machine. Your rail grinding index series of the high productive of the grinding machine consists of 72 stones, 36 stones of each of the left and right of the wheel as right rail. Rotation, each of the done with the independent electric motor of 30 horsepower with the speed of the rotation of 3,600 RPMs. Each motor with the independently tilted the desired angle with the blast from 70 degrees toward gauge face side, 30 degrees toward field side. But the angle is measured from the vertical of the machine is capable of the grinding, planing with as well with the curved track, with the track over the tunnel of the truck. Track on bridges, glue joints, and fish plate joints. Machines can work on the curves up to 10 degrees toward tracks with gradients up to 3%. Check rails provided on the curves if any of the required to remove the prior to the grinding. There is no need to remove the bridge guardrails. Level crossing points with crossing SEJs or axle counter create with the observation error. Skip the raising of the grinding stone. While these features are encountered, it has also observed that the joggled fish plates provided on outer rail sharp curves also create obstruction and should be removed before grinding as far as possible to avoid grinding on the fish plate with the result in excessive wear of the grinding stone. Alright, the machine works on the traffic block. However, no power block is required. Grinding can be done either direction without need for reversing the machine. The machine is capable of running while grinding at speeds ranging of 2.4 kilometers to 24 kilometers an hour, depending on the quantity of the metal to be removed. Generally, the speed is kept at between 8 and 20 kilometers during grinding. Maximum cutting depth is each pass is 15 hundredths of the millimeter to working speed of 15 kilometers or 22 millimeters at a working speed of 10 kilometers. Alright, working parameter of the rail grinding machine. General, the Indian Railways initial doing the preventive gradual grinding on the basis of the target profile to be achieved with the grinding pattern of the grinding frequency suggestion for the RAM Constellation National Research Council Center of the Surface Transportation Technology in Canada After gaining experience, Indian Railway shall decide to shift the preventive guidance of modify the target to profile patterns, grinding frequency accordingly as required. Target profile, the non-rail condition, NRC National Research Center has designed 4 target rail profiles. Indian Railways is shown figure 5.5 below, namely of the contact point central, contact point field, high rail sharp, and high rail mild. Rail wheel contact points of the contact point central and the contact point field are 1-point contacts of the high rail sharp and high rail mild. 2-point contacts railhead shown in figure below. The CPF, the contact point field profile, the contact of the wheel of the rail will shift toward the left side, the field side, test side, while in contact point central, the wheel will take the contact of the right in the center. Show the CPF, the HMR rail profile, HRS profile. Alright, selection target rail. For the selection of target profile with the curve of the more than 1/4 of the degree of the call with the sharp curve of the suggested profile with a different track of location tabulated below. The tangent straight curve of the line of the up. Rail section 60 kilograms of grind template profile is the contact point field. Tangent straight track down line curve. The rail section 60 kilograms grinding template profile. Contact point central. Tangent with hunting up and down 60 kilograms. Template contact point field. High sharpening less than 1/25 of a degree, 60 kilograms and 52 kilograms. The high rail sharp. High mild greater than 1.25 degrees, 60 52 kilograms. High rail medium mild. Low sharp, greater than equal to 1/25 of a degree, 60 kilograms. The central point field contact. Low mild, less than 1/25 degrees, 60 kilograms. Central point contact. Tangent up and down, 52 kilograms. Central point contact. Low sharp and mild up and down, 52 kilograms. Central point contact. For straight tack tube, the profile has been designed as a contact point central would be used down with the track with the contact point field will be the up track with the ideas on the half of the tray with the track with the contact point center compact point on the balance with the contact point field. In the case of long stretch, the single line with the track half is with the demarcated with the contact point center point contact on the other of the center point field. Contact point field. Grid patterns. Loram Constellation of the NRC Canada has designed 49 patterns of Indian Railways of grinding so if the target of the rail profile change of the straight curved track that will be different to the high rail with the low rail curve of the track with the pattern will be selected. We also have a different situation for the pattern shown in Annex 5.2. Only one pass is generally done with a straight track, with 3 passes for the done with a curved track, and with 3 passes for the curved track are done with a straight block, stopping for the machine after the first pass during the second pass, running the machine in reverse direction, again the stop the machine after the second pass, curve the file by the third pass in normal direction for the first pass on the curves. Pattern suggests the Loramus used the pattern second and third grinding passes on the curve suggested by the grinding data management system. From the list of patterns, basis of profiles achieved with the first grinding pass of the known target profile with the target profile known to the machine on the basis of the track data with the detailed tangent curve starting end of the curve etc. with the grinding data management system in advance of the pattern suggesting Annex 5.2. Only first cycle grinding on the section and the 6 subsequent cycles of grinding of the patterns are required to be revised. Alright, so grinding cycle. The grinding cycle suggested by the MSS LAM preventing gradual grinding is below. Shows grinding pattern 1, tangent straight track, middle curve, sharp curves, and test sites. Cumulative grind MT section start grinding, grind 2, single pass, straight track, mild curve 3 pass 18 kilos, sharp curve 3 pass 18 kilometers, test sites monitor profile. Cumulative grinding of the section 75, approximately grind 3, single pass 15, 30 pass 18 kilometers as is a mill, then sharp curve test sites, monitor profile, RCF, the 125 and so on, grid 4, so on, single pass 15 kilometers, 13 PSI, 18 kilometers per mile, and sharp curve test site, monitor profile, and RCF. Alright, 506, monitoring equipment of grind quality. The minnow proof of the minnow proof of the equipment is to measure the profile of the rail head with the accuracy of the 540 thousandths of the millimeter of the contact type of the rail profile measuring system. Mini proof data is useful for the knowing the wear of the rail due to the traffic wear due to the rail due to the grinding, and also to compare with the post of the grinding profile of the target of the profile except for the appropriateness of the grinding parameters. Your bar gauge is a handheld instrument with the measuring profile of the rail head for templates for the attached for the gauge for the four target profiles, namely the CP control point contact and control point field and high rail speed, high rail mild deviation existing profile of the target, high rail sharp, high rail mild deviation existing profile of the target profile quickly known by putting one template over the rail head using a taper gauge to measure the gap and tolerance for the template is given in 5.3 and your star gauge is a form of the template that have 5 different top radius of the instrument. You can make a quick check of the compare with the actual radius of the rail top before and after grinding operation. Digital incrometer of the shoe that denotes the angle of the grind shown in particular with the point of the rail surface by simply keeping the instrument in a particular location. Angle will be known with the digital form. So for the rail measuring gauge, the roughness after grinding is high. With the gauge measuring roughness of the rail, roughness after grinding shall be within acceptable limits less than 12 micron. Alright, rail hardness. The grinding shall not cut in the head of the hardened layer from the rail top completely. This will increase the wear rate of the after grinding. The instrument is used to measure hardness before and after grinding. Working with the rail grinding machine. Feeding of track data. The track prior to the grinding is surveyed for the track data. The feed of the annex X sheet with the perform pro verified enclosure of the annex 5.3. Email to the RDSO. Formatting field of the grind data management system format for the rail grinding machine is done with the RDSO. Patterns and target profiles pre-defined with the machine there, so these can be modified when required. Pattern first path recommended by LRAM. Curve requires 3 passes during the same block. Pattern the second and third pass on the curves is suggested by the grinding data management system on the basis of the rail profile achieved after the previous pass. And final target rail profile desired for the track geometry at this location. Rail grinding machine can work on either direction, therefore the direction of the machine is not required to be changed for the second and third pass and curves. Second lots of the spark generated during the grinding. There is a fire hazard associated with the grinding due to precautions should be taken in this regard. 508 quality inspection of the grinding. Essential monitoring quality of the grinding following method due to the assessing benefit of the grinding and grind quality achieved. Testing site monitoring. The typical test of the represented on the figure 5.6 below with the stretch of the track with covering 3 sleeper spacing divided into 3 parts and the first 4 measuring rail profile min proof marked as MP. The second is taking of the surface photograph. The third of the dying penetrating test or DPT photographs. So you have mini proof, measuring of the rail, surface photographs, and dye penetration. Alright, test site. Each test site is selected as if the representing the 20-50 kilometer length of the track. Enter distance of the test site will depend on the variation and feature of the section explained below. With some of the more requirements of the test site. Separate test sites should be chosen with a different track structures, 52 kilogram, 60 kilogram. For any major change of the gradient formation structure, separate tests should be selected. Typical 1 SSE permanent way section have been minimum 1 test site with for each mild curve, sharp curve, and tangent track. Test site should be accessible by the road and easy for the taking the measurement. This should be a way for signals, level crossing yard, bridges, etc. So to show the stretch of the track, which track normally moves at the normal speed of section. Alright, measurement by min proof. The first portion of the test is marked with the MP with the arrow painted here with the location with the rail profile with the measure every time with the before and the after of the grinding. The closer of the achieve of the profile of the target profile after grinding, the more will by the benefits accruing from it. The essential monitoring of the deviation of the post grinding profile with target profile. This will also help the making of the decision tree with the pattern of the future grinding monitoring contact band. The location of the contact of the wheels on the rail should be changed with the after the grinding rail wheel contact band indicates that most of the wheels shall make the contact of the rail desired with the railhead. Therefore, to clear change of the contact band location, size should be visible after grinding. The contact band is being monitored over the curve of the track before and after grinding. An identification of the contact band with the railhead is done by spray painting the marking, making chalk marks on the rail surface allowing the freight train to pass over. This manifested in the form of erasing of the paint and chalk covered over the band of like formation, detailed location, date, width of the contact band, the distance for the gauge face, etc. should be written and photographed showing the contact contact band and detail of the written on the rail foot is taken for record. A die penetration test. Second portion of the test site with the die penetration test is done to the damage of the rail surface, including the cracks, will become prominent. Die penetration test is carried out before and after grinding. Extent of the reduction number of the length of the cracks indicate the efficiency of the grinding. Alright, other quality checks: monitoring rail surface finish for the condition of the rail top grinding that gives a lot of clue for the quality of the grinding. After good finish, I'd have the regular grinding marks of the grinding shown with the arrows known as facets, which have a silver finish. A bad finish will have the irregular marks of skip grinding at the regular interval with the blue color on the rail's certain location known as bluing, the effect with the regular facet with the width, etc. Facet with the width of the marks left by the grinding wheels should be about 10 millimeters in the center of the rail and 4 millimeters at the corners. Surface roughness after the grinding rail surface should not become too rough after the grinding. The surface roughness level should not go beyond 12 microns after the grinding. Grinding quality index after the grinding of the grinding quality index. The grinding quality index, which stands for the grinding quality index, which is the measure for the efficiency of the grinding with respect to the target of the rail profile. Grinding quality index values 100 indicate that the target profile has achieved fully. Lower value with moves to the deviation from the target profile during the run of the grind data management system screen display. Grinding quality index for both rails before and after grinding separately with the grinding quality index of 80 above the zero acceptable. Crown radius of the railhead measured before and after the grinding of the target. The crown radius should be closer than 250 millimeters at the center of the rail after grinding. Mounting of the RDSO with the performance include with the annexure 5.4 with the field unit with the sent with the RDSO every time the before and after the grinding RDSO they have the toy with the tab with the receive with the different railways. Cite an appropriate grinding parameter for the grinding cycle. The pro forma may be revised by RDSO based on the experience of the gained. Alright, 509, preparatory works, introduction, railway grinding management, railroad grinding machine. Arrange the proper stabilization facility of the machine about every 50 kilometers distance. Identify the railway consumer to deposit the plane time supply with the diesel of the machine. Make arrangements, supply with the waters of 75,000 liters to the machine. Plan an adequate traffic block for the working over the machine. Adequately arrange equipment to take the required measurement to collect the track data from the feeding of the grinding data management software installed within the machine. Note the down of the chain of the level crossing SEG points for the crossing with the axle counter and store with the end of the curve of the direction of the track measurement. The collection of the details should be considered in the direction of the increasing of the kilometer in respect of the direction of the movement of the traffic on that line. Find out the history of the rail, where of the surface damage rail on the rail of the USFD, defect the railway to failures, etc. Section while grinding is being done with the site with the changes in these parameters of the grinding done. Identify stretch of the tracks which will skip during the grinding like rails. Plan renewal in the next 2 years and the rails have severe corrosion, liner, bite, or corrosion, etc. Establish test site. Open separator valve for each of the test site in your section. Pre-block activity before deploying the rail grinding machine. Paint the sleeper with the prominently on either side of the SEG with the axle count of the points crossing with the level of the crossing at the start of the end of the curve for easy identification of the senior service executive, junior executive machine while grinding. Ensure effective communication between the FCC, RCC, and staff on the ground. Counsel for the staff of the gate maneuver to keep everyone away from the machine during its working to avoid injury from flying sparks and iron dust. Counsel the staff of the working on the traffic as well of the railway grinding machine to give the safety gadgets such as the helmet, the goggles, reflective jackets, shoes, etc. during the railway grinding work. Measure all rail profile, mini pro for the Carify with the DPT with the take the surface photograph of each of the test site before grinding and says around 15 days prior to keep the details in the final chronological. While filling the diesel, ensure the diesel does not spill into the rubberized spark guards with which may cause fire during grinding. Operation during rail grinding machine block. On the track, follow on the motor trolley behind the grinding machine. Locate the fire on the track on success to take the necessary action. Check the quality of the surface finish visually with the irregular grinding. Moving of the rail, skip the grinding, etc. Surface face of the grind marks band, which was about 4 millimeters at the corners and 10 millimeters at the center of the rail. Check the surface roughness of the bad condition. See if it is not exceeding 12 microns. Check the profile of the few placed with the straight and curve of the graphic grinding wall of the bar gauge. Check how to close and away from the target profile to see whether the profiles are within prescribed tolerance or not. Check rail crown radius of the target. The desirable radius being about 250 millimeters. Alright, check contact band and straighten with the curved track of the one over the two location before and after grinding. Give the paint truck with every block in addition with the test site with the taking the photograph with the keep the record with the chief of the dust collection system is working properly. Inform or regularly notice for the senior service The senior service engineer and junior engineer of the track maintenance says get it rectified. Ensure the train and flammable materials are not allowed on adjacent tracks during the grinding operation in case there's double or multiple lines on the machine. The senior service executive of the junior engineer of the track machine check whether the angle of the motor, the calibration of the tachometer, the calibration optical rail profile measuring device has been done as SSE JEM track machine as prescribed schedule. Check with the proper function of the water pump, the water cannons, etc. Check all the motors of the work properly through the indication of the HMI panel. Make chart in avoidance of the pattern to be selected during the first pass of the grinding. E. Synchronize the changing of the track change of track on the machine before starting and during the working as required. Check with the pattern specified selected by the senior service engineer, junior executive engineer. Track machinists are correct. See if the grinding speed is correct. Check with the properly engineered. Consequently, sequence of the motors up or down correctly, promptly locate the obstruction. Check with the weather, the direction of the curve of the grinding data maintenance system. Software is the same as the existing on the ground. Do not use the grinding data maintenance system suggestion pattern for the second and third pass on the curve of the case if the direction is wrong, as it may spoil the script of the profile to the pattern manually. Make sure remember to get the grind data maintenance system data correctly and corrected if the direction of the curve is found to be wrong, so that the similar problem is not repeated during the next cycle. See the patterns are changed properly with the service senior engineer and junior engineer track machine over on entry exit of the curves. Check grade quality index, grind quality index before and after grinding to check after their improvement of the grind quality after grinding. Learn working of the grinding data management software, including recommendation for the pattern speed for the second and third pass. For the curve, check the pattern on the the motor, monitor real time. The location of any alarm of the HMI on the machine. Start to see with the senior service engineer, junior engineer track machine takes corrective action promptly. P. While starting with the grinding, the buggy should be lowered on a straight track to ensure that the buggy wheels sit properly on the rails. In case of the curve due to the different wheelbase of the buggy as compared to the wagon, the wheels may go off the rail or on lowering. For the same reason, raising of the buggy is also done on straight track only. Post-grinding operation. Take a rail profile after grinding no later than 15 days after the test at the test site with the carry the DPT test, the die penetration test at the test site within 10 to 15 days of the grinding. Take the photograph, keep it in file. Take a surface photo of the test site within 10 to 15 days after the grinding to keep in file. Preserve the 12 copy of the minimum proof of measurements of photographs. Superimpose the rail profile with the before grinding, after grinding, taken with a mini proof of the on-track rail profile. Analyze the result of the calculate the metal cut deviation from the target profile. Ensure safety disposal of the grinding dust in the yard. Utility track vehicle general. It is self-propelled four-wheel vehicle crane for the loading and unloading of the transportation of the pneumatic permanent way materials like the rail sleeper to the other heavy material capable of attaching hauling one BFR or similar railway wagon holding of the material such sketch of the UTV main components can be seen in figure 5.7. Show of the cabin, engine, power transmission, and crane. Main assembly of the UTV, their functions, cabin is provided. One side of the cabin has seating arrangement of the half of the platform is a flat portion of the UTV. The material can be stacked. Loading and unloading materials can be done on either platform of the railway, flat wagon, or attached with a UTV. The crane with a different model of the UTV. Some of the either earlier model UTV models have the model mobile cranes for the tire wheels mounted on the flat wagon. Capacity 1.5 to 7 ton to 7.5 millimeters radius. The current radius models have the fixed type crane. And so the platform have the multi-stage extension crane has its own power back of the reoperation crane capability. Some of the machine 1/2 10 to 7.5 meter radius, 11 to 12 ton TM, while others have the 2 ton 7.5 millimeter radius. Further plane to increase the crane capacity handling with a service rack and tongue rail 3 ton to 7.5 millimeters at 22.5 ton meters. Engine. The vehicle has one diesel-operated primary movable water-cooled engine with the drive of the vehicle. Also with the crane operation, power transmission, hydrodynamic power transmission system provided with the transit during the working and inspection. Both axles, vehicles, are power brake system. Following the brake system provided with the UTV machine, direct brake service brake with the brake supply with directly hand with the operated valve, the SA9. All brake cylinders, both the axle through with the pneumatic relay valve. When a machine is running, the indirect brake control with the coupled coach wagon. The indirect brake in A9 is applied with the both machine control coaches, wagon, and new machine. The old machine of the brake is applied separately with the cabin and coach wagon. In addition, with the machining brake with the parking brake. Two spring-loaded separate cylinders are mounted down with both the wheels of the axle. With the machine of the brake is applied with the automatically when the air of the cylinder released on the air system. Pressure drops below 3.5 bar. Emergency brake is applied directly on the machine in the case of emergency and immediate stopping. Vacuum brake, separate power pack of the own circuit is provided applied with the camping with the coach wagon have the vacuum braking system model. The UTVs, presently 7 UT model of different manufacturers working with the Indian Railways to sketch each of the machines with the dimension detailed enclosed in Annexure 5.5. UTV 502 with the mobile crane with the Tampa Construction USA. UTV fixed crane 1125 TM Cassidy. Floaters Tampa, India. UTV mobile crane. UTV fixed crane 12 ton M. And UTV BEML India and OPL India Trinidad Engineering Sand Engineering. Alright, 514 Railborne Maintenance Vehicle. The General Indian Railway Railborne maintenance vehicles manufactured for the float task. This is an 8-wheeled vehicle that's designed and running at a maximum speed of 105 kilometers. This is designed to carry man, materials, tools, plant to work side with the attention track sketch for the railborne maintenance vehicles, which main units are shown in Figure 5A. Mentioned detailed railborne maintenance vehicles in Indian Railways are given in Annexure 5.6. Driver's cabin and cabin for one man, air cleaner, radiator, cushion, seat, toolbox, crane, formidable sidewalls, engine, transmission. Cabin 2, form material, driver's cabin 2. Minimum assembly rail-borne maintenance vehicles from the other function driving the cabin to one driving the cabin as each provided with both ends of the vehicle driving in either direction. Cabin for men and material with the 2 additional cabins provided, one of the keep it and maintenance material with the tools, the plant, with the other crane operating cabin staff with the seating arrangement. 12 numbers of the staff can be accommodated within the staff cabin. A crane operation. One hydraulic pillar jib crane that's installed with the vehicle in the middle of the platform. Having the multi-stage extension of the crane has its own power pack for the operation. Loading and unloading of materials is done on its own platform. The no BFR can be attached to the railborne maintenance vehicle. The engine of the vehicle has 2 diesel engine which in under slug position commuted model with the number NTA855R. Each engine drives 1 bogie through independent power transmission. Power transmission railborne motor vehicle with a hydrodynamic power transmission system provided driving as well with the working intersection of these transmission systems are powered with the independent prime mover to give the power to each transmission gearbox. Brake system, following brake system approved with the railborne maintenance vehicle. Direct braking, surface brake. Brakes applied with the control lever SA9 with the both bogies for the machine and have the pneumatic relay with C2W while running indirect with the indirect body. Brake is applied with the machine coupled to camping coach and wagon with automatically through pneumatic relay of CTW with the air press for the B line, brake pressure line release through the A9 valve drops. Parking brake. 2 springs loaded separately, cylinders mounted on each of the bogies. Some of the brakes are applied with automatically when the air of these cylinders released when the air system pressure drops below 3.5 bar. Emergency pressure, these applied directly on the machine in all cases of the emergency of the immediate stopping. Sealant feature of the railborne maintenance vehicle, they payload capacity of 15 tons of space carry, the 2 rail with 13 millimeter length with a 60 kilogram, 2 sets of switch and stock rails assembly along with fittings, 1 cabin to hold small track machines, tools, and equipment to permanent way maintenance material with a mobile maintenance unit, setting arrangement, 12 official accompanying with the railborne maintenance vehicle, and other cabin fitted with a hydraulic crane with the material handling with 1 to end 8 millimeters, lifting capacity had the diesel operated portable generator, 8 kilovolt amperes for generator lighting and work welding and other works. 515 works required before and during after deployment of the UTV and the railborne maintenance vehicle. Front of maintenance way when the material must be handled should be collected and stacked at location when the reach for the crane and broom is in advance. Available the material handling sling with the other select attention should be checked with the instrument before going for the block of the support pass of the post of the flat wagon of the UTV floatable side walls of the railborne maintenance vehicle which infringe the loading of the material should be lowered before starting the material handling is site. Central line with the rail P with the baby handle shall be marked. Longer rails should be cut in pieces less than 13 millimeters in length. 13 meters in length. It should be ensured the vehicles established parking brake on them before the operation of the crane. So the crane should be designed to give a strong wind blow at no more than 50 kilometers an hour. Operators should have a clear view of the work area, ensure that no one is there within the operating radius of the crane. Or the stability of the crane vehicle should be constantly checked on during the maneuver. The operator should check with the detail of the load, with the lift tip of the radius for the operation per the load of the distance diagram. The operator should be careful while working near electrical power cable. The operator should never leave the machine unattended with the booms extend with the load lifted with the ground. Once unavoidable, he must have the maneuver the load to the ground and turn off the vehicle with the load. Unloading and material handling should be preferably done from the cess of the side of the track in case handling material between the two tracks will be on the adjacent running of the track with proper track protection. Adjacent track should be done. Crane movement of the front side of the shall be locked during the working with a single point of the sling of it should be avoided. The broad risk of the ending of the damage of the rail slack. The overhang shall be no more than one half the distance between the two lifting points. Loading over the rails and sleep of the BFR of the UTVS rail-borne maintenance vehicle should be normally limited 4 to 3 layers respectively. The rails shall be kept horizontally straight while lifting or removing the supporting port forward on both sides of the wall shall be lifted up. The rails shall be tied with the chain that screw the rails after completion of loading before the move to loading and should be uniformly distributed. Eccentric loading should be avoided. Crane should be handled carefully with electrified territory station yard. The staff should not be stand below with the suspended load of their safety. Staff should wear protective goggles and industrial shoes to minimize the risk of the injury. Items specified with the UTVS. The permanent away should work as a guard on the machine. The guard, along with the machine staff, should be deputed with on the BRN for the safety where the machine moves over the crane side of the attached BRN. Flat wagon should have the valid brake BPC moving it into the BRN should be provided with a detachable handbrake operating lever. Item of the railborne motive maintenance vehicle with the tools and plans prescribed by the mobile maintenance units and should be available to working order. Payload should be not more than 15 tons. Staff should wear distinctive color helmets, clothing of the easier identification by the crane and machine driver to avoid accidents. Alright, Annexure 5.1, important feature of the dimension of the rail grinder control car. You got a pattern sheet to show the different rail profiles. Performing data over the field fed by the grinding data management system. Rail grinding monitoring program A for the site identified monitor shows visual inspection corner chipping, flow over the rail top burning gauge, corner fatigue, crash pitch, wheel burns, scrapping, any other defective corrugation, one pitch, hunting pitch cycle, type of contact wheel on the rail, 1 point contact width. Position central level, the gauge side, face side, man, the 2-point contact width, the position central line from the gauge face side, millimeter multi-point contact width, position center line with the guide face side, millimeter contact patch width, the point is center from the gauge face side, millimeter. Your wear pattern over the rail, gauge face, the top table, the track geometry, gauge, cross level, unevenness, alignment. Route specific, and then it goes over the route. Important feature for the dimension of the utility track vehicle for the rail-borne maintenance vehicles. Cabin 1 air cleaner, radiator, cushion seat, toolbox, hinge, biller, crane, jig crane, hydraulic operated telescope, cabin. Chapter 6, planning and deployment.